All right, so flat rate depreciation, nth term. So this again is a little bit like finding the nth term for simple interest, but the only real difference in the rule, as you can see down here, is that instead of adding, we've got a subtraction. All right, so that's the key difference, and basically the only difference. So please remember that flat rate depreciation is used when the value of an asset decreases by a constant amount each period. This amount is dependent on the initial value. All right. Here we've got VO, as always, is the initial value of the asset. All right. R is the flat rate depreciation. All right. So the rate of depreciation. And the value of the asset after n years. All right. So we can sub in any value here to find out the value of the asset after it's depreciated across a number of years. Alright, so here's an example. Jimmy bought some real estate for $670,000. Nice house. Go Jimmy. He bought it in an area that he thought would be a high growth suburb. Unfortunately, it is not, and his property is now depreciating yearly by 1.5% of its initial value. Bad luck, Jimmy. So it's actually depreciating rather than gaining capital. Right, so write a rule that calculates the value of Jimmy's house after n years. All right, so we know that our rule is going to come in the form of Vn equals V0 minus Nd. All right, so we need to create the rule. We know that V0 is equal to 670,000, and we know that D is going to be equal to R over 100 times V of naught, and we know that R is 1.5 over 100 times 670,000, which is equal to $10,050. So now that we've found our D and our V naught, we can sub that into our original formula. So V of N is equal to V naught, which is 670,000 as we just found, minus ND, which was 10,050. Awesome. So we can use that rule to find the value of the house after any number of years. So the next question says, what is the value of the house after 3 years? So we found this rule on the last part. So let's sub in our value of 3 years. So V3 is going to be equal to 670,000 minus 10,050 times by the number of years, which was 3. The value of the house after 3 years is going to be 639,850. So it's depreciated in value. So the next part is looking at unit cost depreciation and finding the nth term. So once again, we can use the rule below to find the value of the asset after any number of units of use. So very similar to flat rate depreciation, except for unit cost depreciation, the asset is depreciating after a number of units of use. All right, so for example, a photocopier may depreciate in value every 10,000 sheets, or a coffee machine may depreciate in value every 100 cups of coffee that it may make. All right, the rule we use is V of N equals V naught minus N times D, except unlike in our flat rate depreciation, D here is a set amount. All right, it's not a rate, it's a set amount for each unit of use. Let's have a look at this example. So a computer Mr. Ryan bought for $2,000. Don't know where he got that money. Depreciates by 0.32 dollars for every hour he uses it. So by 32 cents for every hour he uses it. It's probably worth nothing now. All right, so write down a rule to find the value of the computer after n hours of use. All right, so we know that the rule that we are going to use takes the form of V of N equals V of naught minus N times D. Alrighty, so V of N is equal to V of naught, which is 2,000, minus N times 0.32. B says, what is the value of the computer after 50 hours of use? All right, we are going to sub the 50 hours of use into our N. So V50 equals 2,000 minus 50 times 32 cents, which gives us a value of 1,984. So the value of the computer after 50 hours use is $1,984. So, part C says, on average, Mr. Ryan will use his computer for 40 hours a week, at least. How many weeks will it take the value of the computer to halve? Alright, so, firstly, we know V of naught is 2,000. That was the original value of the asset. Now, we want to know when V of n equals 1,000 or less. Alright, so we want to know when it'll be half its value. That's what the questions are, the value of computer to halve. Alright, so we know that our formula needs to be Vn equals V of naught minus Nd. And it asks us how many weeks it will take the value of the computer to halve, but first we need to find the number of hours because that's what it depreciates in. So we're trying to find n. This is where you need to recognize that you need to use your solve function in your calculator, right? V of n is going to be equal to 1,000, and we know our d, which is 0.32 cents per hour. So in your solve function, you're going to write solve. All right, V of n is going to be 1,000. I'm subbing the values into this formula here. Equals V of naught, which was 2,000. All right, minus n, that's what we're trying to find, times 0.32. Right, comma, we're trying to find n, close brackets. Then you're going to press enter in your calculator, and it is going to tell us 3,125 hours. Alright, that is how many hours it will take for the computer to be of value of $1,000. Alright, have we answered our question? No, because it asks us how many weeks. So, in the question it said that Mr. Ryan uses it for 40 hours a week. Alright, so we need to take our 3,125, divide that by 40, alright, and we find the answer to be 78.125 weeks. Alright, or 79 weeks. Alright. The reason it goes up 79 weeks is we don't round down, because at 78 weeks, well, it's still worth more than $1,000. At 79 weeks, it may be worth less than half, but the question asks how long will it take the value of the computer to halve. Alright, so it would be 79 weeks.